Hi, this is Aaron from Doodle Labs. Today I'm going to be demonstrating our ultra-reliable low latency communications, or URLLC, using our smart radio products. So before we get started, let me go over our hardware configuration. Okay, so what we're going to be doing is we're going to send video, we're streaming video from this Raspberry Pi, and the camera is actually pointed at this monitor here. And the video is going to be streamed to this PC here. And at the same time, the PC is going to be pinging the Raspberry Pi. So we're actually streaming the video over the network to a smart radio inside this box. And we're emulating the RF path with these digital step attenuators so we can control the path loss. So inside this box, you can actually see an RM22502H smart radio. And we have an identical setup in the other box. All right, let's go over our software configuration. So in order to enable URLLC, we go to Network, and then Differentiated Services. And in the Differentiated Services page, we're going to enable Command and Control and Video Optimizations. And we want to add two rules. The first one is to send our Command and Control over port 2000 using the CS6Q. And for our video, we're going to use port 5000, and we're using our CS5 video queue. Then you want to click Save and apply the exact same settings to both radios. Okay, so how are we going to do our measurement? We're actually going to use HPing3. HPing3 allows us to measure round-trip times using TCP packets. So in my top window, I'm going to be sending my command and control over port 2000, so using HPing3. In the second window, I'm going to be doing the same thing, but over port 9000. And in the third window, I'm actually printing out the RSSI as measured by the smart radio. And lastly, I'm showing the video screen. So let's go ahead and start running HPing3. So in this case, you can see that the signal quality is good. We're getting about minus 70 dBm, and as a result, both queues show very similar latency, around 3 milliseconds. So now what we're going to do is go ahead and add an additional 20 dB to the path loss. And you can see that the signal has gone bad. It's around minus 85 dBm, thereabouts. And in this case, we still have a very good latency in the main queue, while for the port 9000, the random queue, it's a little bit jittery. But this is going to start to get worse. I'm going to actually add another 4 dB. And now we're reporting about minus 90 dBm per antenna. And you can see some pretty high latency results, up to around 67 milliseconds in the port 9000, while port 2000 is still reporting good latency numbers. And let's just go ahead and add another 2 dB. Now in this case, the signal strength is extremely bad. It's around minus 92, minus 93 dBm. The video has practically cut off. The latency times reported on port 9000 have gone quite high. They're very jittery, and we're getting in the hundreds of milliseconds sometimes, while our URLLC is still reporting typically below 30 milliseconds in most cases. So I think this should give you a good idea of how the URLLC works, how you can use it, and what kind of possibilities it presents.